Welcome to another live stream, Friday live stream. This is Retainer Designer. My name's Cade, and I do videos on OrthoLab stuff like appliances and equipment and reviews and that kind of stuff. So glad you're joining me today. Let me know in the comments below where you're from. I always like to figure out where people are watching from. It always interests me. I think I got a comment. Let's see here. Good afternoon from Brazil. Oh, Luciano, so good to see you again. Glad you're there. Anybody else watching, just put in the comments below. If you're watching on Facebook, I think you got to do a weird connection, approve that I can see your name, because I want to see your name in the comments below. But today, let's get started. Today we are doing a special RPE, as you saw in the thumbnail. So RPEs are changing. We're kind of in a transitional phase right now with RPEs, and that's due to new technologies, so things such as 3D printers, 3D metal printing, that kind of thing. Today I'm going to talk about the middle part, the in-between phase. I'm going digital, but I haven't gone all the way digital, which means 3D metal printing. And I got some pictures of that and how that goes. And I'll cover that in another video. But right now I'm covering the transitional phase of RPEs and all the little different phases, I guess you could say, of what you can do with a 3D printed, making a traditional, what I call a standard RPE on a 3D printed model. I'm going to bring up a thing here. Okay, so here is my little pictures I have and options that I have for things. As you see in the picture, we got a model, we got a standard RPE. I got the model over here. Alright, I've got the traditional RPE. I can show it under here. And I got a couple bands. If I can get them out of here, I got a couple bands. So we're having the regular standard RPE, but on a 3D printed model. So what are the options? Again, you can still do the standard. So this is the standard. This is a picture I pulled up off my website, and it's just a standard stone model. The bands are placed in the model. As you can see, they broke off during the process, and so that is. A lot of these will correlate. You're just starting differently with a 3D printed model. Now, there is one transition step above that to 3D printed models, and it is to print the 3D printed model, alright, and then duplicate it into stone, alright, and then work on the stone like you normally would. You can solder on it and everything. What changes with this, these you cannot solder on. They are impossible. They will burn, they will smoke, they will look terrible, they will gas you out. So you got to change your technique a little bit, and that's what we're going to work on today. But let me go through a little bit of a background. So now you have bands, okay? So you have a 3D printed model. Let me show this real quick. You have your 3D printed model, and as you can see, I've digitally ditched the bands. But where are you going to get the bands from? So here's the thing. You got bands. They're provided by a doctor. Okay, like I have one right here. I'm going to switch over real quick. I have a case here right now. I have a 3D printed model from them, and I have bands provided by them. And they send the bands in. So that's the tricky part. The doctors are going digital, but you can't make the bands digital unless you get a 3D printing. And then that's another story. That's another video. But how are they going to get the bands to you? Well, the bands can be provided by the doctor. So just like in the plaster model that we just saw, the bands were provided in the plaster model. You can't do that with 3D printing because the 3D printing is happening here. So the bands have to be provided externally. So if they're provided by a doctor, in that case I just showed, that doctor actually there's an assistant that lives 11 minutes from my lab, and so I'll go pick it up, and he'll send bands home. Send me the digital model separately through my 3D print, through my software, and then I'll get the bands through the assistant at our drop-off location. And so that works out perfect. Now, the other option is a band kit provided by a doctor. So this is a band kit, and let me show you this up here. Let me switch over to this camera. I'm sorry for all of them. It's a windy day today. Up here I have my bands. All right. Oh, you can't see very well, but you can see there's some band stacks up there. I have the one I'm working on today. They have given me a copy of their band kit, and I've labeled them with their office name, but they've given me the exact copy of their band kit. So that means that when they give me that band kit, there's two ways to do that. They can the band kit's provided by the doctors. The band sizes are on the RX. So on here, if they send a digital scan, they can actually fit their bands in the patient's mouth and then mark on the prescription what sizes they are. Then I go into their kit and I pull their bands, size 17 on the left, size 16 on the right. We know they fit the patient exactly. So that's what we do. The other option is same thing with the band kit. We got the band kit, but lab has to fit the bands. Okay, so they still provide a bands. I give a discount to the doctor because they're providing the bands, and there's a little extra thing where I have to actually send them a picture, kind of like what we did here. I have to send them a picture of the empty spots in there, and so I'm like, hey, give me these bands. I'm out of 20 and 22 and 23 on the upper right side. So that's what we're going. That's the band kit thing. So the other option of that, so that's doctor provides band kit, like what's shown. They can give you the sizes. They can fit chair side, and then just give you the sizes. That way they don't have to ship any bands to you. And the first one's bands provided by doctors with a 3D printed model. They have to get the bands to you physically somehow, either shipping or you got to go pick them up, which kind of defeats the purpose of 3D printing. You know what I mean? It's still got this physicality to it that you need from them. So we got bands provided in a kit. They give you the sizes to pick from the kit to use on there, or they trust the lab to fit the bands to choose the right size, or bands provided by lab. So that's what we're dealing with, is what I don't like. Sorry, my rooster is very loud today. I don't know if it's the wind or what, but yeah. So I do have my own stack. This is part of it, of my own kits, and I'll pull from these kits. And I charge extra for that. I charge a lot more if I have to provide the bands, because one, if the band doesn't fit, I gotta remake it. And so I usually don't charge for a remake, but I build that remake price into choosing my own bands. So we got a comment. Jason Brown, hi, how you doing? So good to see you here. Glad you stopped by. And so that's where we're at. So what this case is specifically is the bands have been provided in a kit by a doctor. So that's this kit right here. Now I've already pulled the bands that fit, and my preference is if the doctors actually fit the bands in the patient's mouth and then send me the sizes to choose from their kit that they keep at my lab. And that's my preferred method. That way we know they fit exactly. Or, in this case, they can send the bands, but, you know, like I said, it defeats the purpose of digital. But that's what this video is for. This is the transitional video between analog, digital, the classic method. How are we going to do it? Now, Jason who I just brought up on the screen, I know they duplicate, and so they take out the whole problem of all this. They can send the bands, duplicate, they put them on the plaster model, and it goes from there. They use the same techniques all the way through. So I have already fit these bands otherwise, you know, this is kind of what it looks like. Let's see, this is upper right. I have to take the bands here, and let's say I try a 26, and I'm like, oh, that actually fits pretty good, pretty snug. Some of the things I need to do is sometimes this hook right here on the side, I have to, let's see if I can get that off. Well, there we go. Maybe too good of a fit. I actually have to carve this just a bit. You can see you can't carve the 3D printed model very well. So that actually fits better than what I did. So let me switch out to this one. So that's a size 26. I'm going to put this size 26 back in here, and I'm actually going to need to call them and say, hey, I'm out of 26s now. So I actually will wait till I'm out of a few of them, and then tackle it all at once. Sending out the cases, or I'll usually send them a shipping label just to be nice. There we go. Now let me get a band pusher here and get these on here. I feel like I could go a little tighter, but I'm a little afraid to do that because I don't know what it looks like under here. So as you can see, I have digitally ditched these, which means while this was a digital file, and I wish I would have taken a picture of this, while this was a digital file, I could have taken a picture. I wish I would have taken a picture. But you take the STL file and you go ahead and ditch digitally and then print it, and it prints out this way with the ditch already there. Now you got to get pretty good at ditching these, and I think I did pretty good on here. It looks, let's see if I can zoom this. That looks pretty good, but still I'm not 100% sure that this, is there. So that's why I fit a little larger, and if it's too small, it won't fit at all. If it's a little big, it'll still fit the patient's mouth. Granted, it probably won't be as stable, so the doctor will have to tell you, or sometimes the doctor will just tell you, hey, just Kate, overall fit my bands tight. But I haven't gotten that from any of the doctors yet, so I guess they've been liking the way I fit my bands. So I have those, and I have it set. I'll adapt it a little bit. There we go. Now, before I forget, there's some more in my little presentation here. Let's go with, let's do this. So in my little presentation here, I want to go over the 3D printed metal part. I think it's very interesting. And then in the comments below, which method do y'all use for your 3D printed models? Hello, how are you doing, Hygiene? DV? I like that. Nice to see you. Glad you stopped by. But everybody put in the comments what y'all use is your method. Do you digitally ditch the bands? Do you duplicate the 3D printed model and then make your RPE? Or do you go full digital? And so that's where I'm going to cover on this. So this is actually a Haas, but this is kind of what a 3D printed framework with bands. So this is bands, 3D printed metal. It's a beautiful job on this. By the way, D3D is who I use to print my metal, and they design it also. So that's what it looks like off the model. That's what I get in the mail, and then I just put it back on the model, and then I just make my Haas. So for some reason, I can't find my pictures of my. I have one, and it's coming up, but it's not a very good one. This is what the metal framework looks like for RPE. Oh, hello! So good to. I'm glad you're here. And so you can see there are support arms. I don't even know if you can see this, my mouse on here, but you can see there's little support arms going across. So here's a picture of one of mine in pre-polish, but this is a 3D printed framework with a CAD-CAM screw on there. I just work handly, no printing. So that sounds like you just still work with plaster, possibly, or you're doing this method. So good point there. So this is this is pre-polish. This is 3D printed framework with a CAD-CAM screw on there that I laser welded. Now, in the link below, I have a link to a video you can watch after this, and it is Leone. I use Leone screws, and they have a software, and I got to play around with it when it was in beta. And you actually get to design the framework the way you want it, which is really cool. So this is the actual digital designing of the framework. This is it coming out of the printer. I took just screenshots of this video, but I highly suggest watching that video. And then this is them putting the screw on it and just pretty much drops into place. And then this is them laser welding. Now I use a Puck D3, P-U-K, D3, and it's TIG welding, so it's got a little sharp electrode point, but I get it done the same. So that's them laser welding it on the framework. And then they're pretty much done with that. So that is where we're at. So now, again, I'm working with the hybrid method. I don't know what to call this. This is the standard RPE on a 3D printed model. And this is the main way I do my RPEs nowadays. I would love to do the sintering, but it costs the doctors more money and they're not willing to do that. But man, what I've gotten from the doctors that do it, the accuracy of the 3D printed, sintered is another word for it, 3D sintered metal framework, is the fit is unbelievable. So I have a model here. So my goal today is I'm going to attempt to make this start to finish. I'm going to build the framework, I'm going to laser weld it, and then I'm going to solder it. I'm going to show you a little solder trick that I use. And then as you're watching, if you have a tip that y'all use that you think would work great, put it in the comments below. I'd love to read it. But let's get started. All right. So again, this is 3D printed model, digitally ditched bands, and then I have fit the bands from the band kit the doctor provided. So it also, the prescription of the bracket matches the prescription of their brackets. So it's copacetic in that way. So let's, that is not what I wanted. Let's do this. Okay. I use 036 wire. Let's get a little tube of scrap wire here. And make sure, I'm going to measure it because sometimes my thing gets, yep, 036. I'm going to round off the end of this. And then let's get to bending. Not my favorite plier. I don't know where my favorite plier is. You ever lose your favorite plier and then you're just lost throughout the day? I might look over at the thing. And yes, I do have a duck cam, but there's no ducks out there right now. It's kind of empty. So hopefully we get some ducks out there playing around in the water. But yeah, let's see. I'm trying to get in the camera angle here. There we go. So this is just normal wire bending like you would do on a plaster model. But when I get to the band part, the band portion, I'm actually going to be very careful adapting it to the band, because when I show you my laser welding, I call it laser welding, it's TIG welding. I'll show you my laser welding technique. These are my favorite pliers. I just must have not seen them that way. Okay, so usually if this is plaster model, I would mark it right there and cut it, and that would be the end of that. Then I would stick it to the model, and then I run the back leg of the RPE up to there. But I'm actually going to go full width of the band, because then I'm going to tack the arm, the RPE arm, to this 036 wire instead of the band. The band, dealing with these bands, you'll find out it's easy to blow a hole in it when you're doing TIG welding or laser welding or plasma welding, whatever you want to call it. And so I'm very careful putting the this part, trying to adapt it very closely, and then whenever I'm actually welding it, I do my best to try not to blow a hole in the band. That is not fun to deal with, because then I'm going to apply a little bit of solder onto the top of it. There we go. Do I have a better picture? I do not. I do not like that picture. Let's go back. So I'm going to, I haven't heated up my wax yet. So I have this pretty much where I want it. I'm going to lift it a little bit up, put a little step in it. There we go. And I'm starting to see just a little bit of space. Hopefully y'all can see that. I'm going to zoom in just a tad. There we go. I see a little bit of space, which means I'm not going to be able to weld there. So I'm going to put my 3 prongs on here and try to end that flush against the band. So the better you can do wire bending, the better your weld is going to get, because man, that gets really tricky. That is one of the biggest disappointments, is you think you're a good wire bender and then you look under the microscope. Working under the microscope, so the wire bending it is real precise. You'll find out how bad you are or how good you are when you get under the microscope of your laser welder, because you're going to be like, whoa, my wire's not touching at all. Because before, when you just soldered, you could fudge a little bit with the solder, you could fill it in and stuff. Oh, so we got a question which actually has to do with wire bending. Do you have an issue working on gray models, and do you ever make yellow ones? I have made yellow ones before. At the time, the resin that I use Formlab printers, and I use draft resin. So this is draft resin that I'm working on. But the yellow version, the like buff colored model, yellow color, I did like working on them a lot better vision wise, because a little bit more opaque, but they were more brittle. So trying to take them off, they'd break on me and I'd get so mad. So I like the gray the best, the Formlab's gray, but it takes twice as long to print. So this model would take 2 hours to print just by itself in the printer. With the draft, it takes less than an hour. So, but it is opaque enough that my wire bending doesn't suffer too bad. And it's slick. That's the other thing, is I'm used to having a little bit of roughness, a little bit of I don't know what you would call it. The wires slide on it a little bit more. And then again, doing acrylic on it, it doesn't absorb any acrylic, so you use a lot less monomer when you sprinkle directly onto these. And of course, you gotta deal with it sticking to the model. So yeah, I have worked with yellow ones before. I wouldn't mind trying it again. They've probably modified the resin now. So yeah, I'm keeping my options open. Right now, just buy a ton of draft resin and print everything in draft gray resin. And again, I use Formlab's and that I use their resin. Alright, so let's do the other side. Hopefully, we'll find out when I get under the microscope. Could never get the, if Lampert is watching this, contact me. I want to buy a HDMI adapter or something for my laser welder so that y'all can see what I see in the microscope. Right now I got a little camera attached to it, and hopefully I got close enough that you can see what I'm doing when I get to that point. But we'll see. But I would love to show it in that. There goes Pete again. Pete the rooster. I'm going to have to share a picture on here when he starts crowing in the background. Still don't see anybody at the duck cam. What I should do is set up like super chat so that it drops some mealworms out there for the duck cam. And alright, so I got this one done. And I don't contour a lot, but yet I don't do straight. But I can see doing straight, and I see the benefits of both. I kind of do kind of in between. So I think that is really good against the band right now. And I'm just using sticky wax to hold this, because the laser welder, it will get hot, but it's going to have to get really hot to melt it. It does happen, trust me. If you're waxing and getting oh, that's a little low. Get back up there. Get back up there. There we go. So another method, I can push against it, and if I see the wire move, that probably means that I don't have contact with the band. Yeah, there we go. Okay. I think we are good there. So let's try laser weld. I'm going to add just a little bit of sticky wax here just to get it to do it. Quad helix demo. You got it. I think I got one coming up soon, so I'll try to do a quad helix demo. I hand bend mine. There are some that use pre-bent ones, which I kind of want to try it out because my hand bent ones come out different every time. I'm not that good at quad helix, but those usually I put on stone models, but the bending of it's the same. You have a separate microscope setup with the LED. You can buy it on Amazon for $60, $80. Put it on your desk. Look like the voids. Oh, I'll look that up. Yeah, thank you for letting me know. I didn't even think about it being a separate thing, a separate microscope setup. So then I can just put it at an angle. The good thing about the microscope setup on this, if I get to the right one, good thing with the microscope setup on this is through the microscope, it will actually it'll flash black when it does it, so you don't ruin your eyes. Now, through the screen of YouTube, I don't think you're going to get hurt with it. But yeah, that's a good idea. Thank you, Perry. I'll look into that, see if I can get a separate microscope that I can plug in HDMI. That's a great idea. All right, so time to TIG weld. But first, I just realized I think I need to sharpen my electrodes. So let me get that going over here. So I buy these electrodes. I don't have, they're 0.06 electrodes. They're just like, they look like pieces of wire. But if you want to get your best weld, you need to have the sharpest. Oh, get over here. So this, I have a little, it's dusty. Ooh. I have this, I bought it from, it's actually from Lampert, and it has a little button here, and it has a little disc. And so what I can do is take this, lay it flat, and it gives me a sharp point. So I'm actually laying it against here, and then I'm just rotating it with my hand. So as you weld, your tip will get dull. The sharper your tip, the better your weld is going to be. And that's a very important thing, especially with the laser welders. I guess you really don't have to deal with this. So that's one of the advantages of laser welding, but they are super expensive too. This unit probably cost me, I think it cost me $5,000. Not this. This sharpening unit was like $145, but well worth it because I didn't want to have to change out my burr on here every time, and you know what I mean. If you get good, you can actually do a few of these at a time. And yeah, I've seen them do like 4 at a time, but I just end up doing it. It didn't take long. So, and then I put them back into this foam thing. So I know the ones that are sticking up are freshly sharpened, and the ones that are in the laying down flat are the ones that need to be sharpened. And I pretty much change out these electrodes once appliance. Every appliance I change it out. Trust me, it just saves time and frustration. Alright, so I've got that. And let me switch this over. So I pull off that tip, pull the electrode out, put the new one in, and it's a little bit out of the shot, but there's a, well, it's got a little measuring device that allows me to put it in at a certain depth. That's important for this machine. Then I just put the tip back on, and I insert it back into my holder here. Alright, so moment of truth. We're going to see how this, let me turn my hat backwards. I got to undo my eyes here. So, okay, we're pretty good. I don't know if y'all can see very well. I wonder if I can zoom in. Ooh, that's pretty good. You can just barely see the tip of it. So, let's try that. And then hopefully it won't flash too much. Alright, I'm going to take my little grounding wire here, and what I do is I go in between the, oh, I have the wrong setting, and I just blew through the band. So wonderful. You got to see that live on live stream. So I'm kind of bridging the gap between the wire and the band, okay? Now, it caught me monologuing. I didn't check my settings. Yeah, I blew a pretty good hole in there. Now I'm going to turn this around. Maybe you can see the hole in there. I'm not sure. I'll switch cameras real quick. Well, it looks huge under the microscope, but it's there. Let's see. Yeah, Jason. That's how you don't do it. Yeah, don't follow me. Don't. Yeah, don't. You see this? This is the picture of how you don't do it. All right. Yeah, that's how you don't do it. 100%. So I'll show you my little fix in a bit. Let me go ahead and get this other side done. Now that I got my settings, and I'll turn the camera around, remind me, to my settings on here. So can y'all see that? Oh, switch cameras. There we go. So I'm just getting my electrode tip. I'm trying to touch both the band and the wire at the same time. And if you want to default to one, default to the wire. And I just run the length of it. So you actually have to start where your wire is actually bending, or sorry, touching the band the best. And then you can just run the length of it. So actually, I got it. So there you go. I did it on purpose. I did a how you don't do it and then how you do it. So that is that being set up. Alright, so my fix. My fix involves a tiny piece of wire. Alright, I got this 020. Let me cut the tip off real quick. And I'm just going to laser weld this little piece of wire. I'm going to bridge that gap right there. Let me clamp this on here. Oopsie. I'm going to bridge this gap. Let's see if I can. Yeah, there we go. Sometimes you have to just do a slight adjustment just so it fits in there. So tack it to the wire. And tack it to the band. I gotta get it at the right angle or it's not gonna work. Yeah, come on. There we go. I'm going to actually just bend this back and forth, break it off. So now I have just a little bit of, actually I just pulled that all the way off. I guess I didn't get a good weld. Alright, plan B. That's one of the bad things about this 3D printed model business is I can't use my thing as well. Alright, so plan B of fixing this thing. I need to actually just hold this in place. I'm sure that is hard to see. Hopefully you are able to see that wire. Oh, I got a comment. What apparatus do you dislike making? Of all of these, my favorite is 3D printed metal. It's just easy. 3D printed metal is the way to go. It's the future because you print the 3D model. You print the metal and you put the metal on the model and you laser the screw on. Done. You high shine it. You're out the door. This one is a hybrid of the two. I don't like doing this as much. So maybe this one. Maybe I'm making so many mistakes. This is the one I dislike now. So we'll go with that. All right, Pete. I know I messed up. There we go. So if you're coming in, I just now blew a hole in my band. I'm trying to fix it. So I'm going to clip this. I'm going to actually wax it to my existing wax so I can hold it better up against that hole I put in the band. So pretty much what I'm trying to do is, so I have a hole right in the band and I have my wire going here. So I'm trying to put a second wire in there to try to give it structure so when I put my solder in there, it goes in there. The worst thing is if the solder goes through the hole on the back side of the band, so you got to really watch out for that. But my soldering technique helps to counteract that a little bit, and I'll show that to you in a second. So let's go back to here. I'm going to switch out my, the good thing is you can just use the other side, switch out my electrode here. You can use the other side. I'm going to measure it. Put the cap back on. And yeah, so let me laser weld this and that and do it here. Okay. Still not exactly what I want, so I'm going to push it in. Now sometimes it just does not want to take, there we go, got it. So I got it tacked here and here. So I'm just going to clip off that remainder. And that is all just going to be into the 100% is just going to be covered in solder. So if you're really good at this, oh, you didn't see any of that. That's okay. It wasn't very good. Let me switch cameras here. So I put a wire, a small little wire, and I span the little hole from here to here. If you are watching on YouTube, there is a gear. I am live streaming this in 1080p. So if you're watching it, there's a gear somewhere. I don't know, over here, a little gear icon. You can change what you're streaming in. You can force it to stream in 1080p, so you can see these small little things we got. Little hole. So I have attached a little small piece of wire crossing the hole. I have attached here, and I have attached the band here. And again, that's just going to give me a little structure for when you blow a hole in a band like you're not supposed to. Alright, so this thing has flared up on me. I think there we go. So I have somehow messed this up, so I'm going to just do some small, quick little adjustments here and here. There we go. So, RPE time. So, like I said, I do use Leone, the 620. I don't know if you can see that. And it's just your classic RPE. Nothing fancy. What we've been using for years and years. So again, always arrows go toward the distal, so I need to flip that around. And I'm going to go ahead and pre-bend the arms up. You can buy these arms pre-bent also, but this part really doesn't bother me to bend it. So trying to get it positioned where you should position an RPE. Alright, so now here's a little jank method that I use. I use a little bit of wax and I fold it up a couple times, lay it in the roof of the mouth. Now here's a part where you could take a pencil and you can mark the midline. I don't know if this is coming through the camera, but just know I can see it. And so I'll put a little bit of wax there in the roof of the mouth, and I'll take my torch here. I'm going to heat that, melt that wax. Again, don't burn your model. You'll know it'll start smoking. And then I'm going to seat this in here, and I'm just going to put it. I'm not worried about the arm placement right now. I'm just trying to get it right where I want it. I don't want it all the way into the roof of the mouth. Oops. But yeah, I don't want it to, I want it in line with the midline. So I'm going to shimmy it over. And that's what I like about the wax. It stays soft enough, long enough that I can make some final adjustments before it starts cooling off. So we're going to let that cool for a second. Yeah. And I'm actually looking at it from the underside here, making sure the key has access. So this actually may be a little more forward than I want, so I'll pull it back some. And then if you mess this up, all you really have to do is just reheat the thing again. So while that's Perry, well, I asked some questions. You said this is hybrid. Why? I don't know what word to use. So we're using standard RPE method of creating an RPE on a 3D printed model. You would think as we went digital, going full digital 3D printed metal. It's not adapted fully yet. So I'm using the old school method of making an RPE, the classic standard method of making an RPE. You know, taking a standard RPE, bending the arms, bending the lingual arms, and then tacking it together and then soldering it, instead of just grabbing a 3D printed and put it on 3D printed. So I'm kind of, the hybrid is I'm taking what we used to do on plaster models and adapting it to 3D printed models. So it's kind of a hybrid. Probably the wrong word to use, but that's why I call it the hybrid method. Is I'm doing the two different ways of taking the two, putting them together. So, and that's how a lot of us are working now in this new 3D environment, getting our 3D models from the doctors and trying to adapt the way we learned things back in the day on plaster models and trying to transfer it to a 3D printed model. It works sometimes, it doesn't work sometimes. You got to find out what you need to do, but that's the reason I call it a hybrid method there. Thanks for your question. That allowed the wax to cool. So now when I pull this up, I have a slight impression of the back of the screw on here. So now when I bend the arms, it can always lock in there. So actually, I'm going to press on it a little when I put it back. I kind of want more of an indentation here, so I'm going to just press just a little bit. There we go. Make sure it's in the midline. Okay. I'm just going to rock it to release it a little bit. Come on. There we go. So now I've got a little bit more of an indentation. So this is now where I adapt the arms. And I'll do this method on plaster models also. And that's just other people, put in the comments below what you use to hold your screws in place. Some of y'all don't. Y'all just bend it the way it is, and you'll just kind of hold it with your hands, and then use a little wax to hold the screw down, or glue or something. Some use like window caulking, which isn't bad. By the way. It's just weird. And then some use Ty-Core material, like almost a clay material. Some use lab putty. So put down below what you use. I just use pink base plate wax. I don't have to worry about it melting out. I do have to worry about that melting out on plaster models, because I'm actually soldering on the model. This we're not going to solder on the model. We're going to take this off and do that. The dance, and I assume you mean the dance between standard and new, trying to figure out how to do that between. Yeah, I feel you. So let's go to bending these arms. And I think I almost put my wax in the wrong spot. They do make a RPE bending arm. I have it over here somewhere. And you can use that to bend these arms. You can buy them. I think this is made by Leone also. So I'm going to just bend these arms out. Let's back this off a bit. Move this out of the way. Get out of here. Let's move this forward a little bit. The good thing about this sticky wax is it's not needed now. I have it laser welded on the model, so I really don't need it anymore. So if it's in the way, I'm just going to pick it off. And the good thing is you don't have to have a super clean for the laser welding. It helps, trust me, it helps. But like I said, you don't have to have it super clean. That has lifted a little bit, which sometimes happens when you're laser welding, so I'm just going to bend it down. Love these 3 prongs. These are from, I got these are Dent something. E.A. Beck, it's not even Dent something. Alright, so I got some of that wax out of the way. Now these back arms, these distal arms, I'm just going to lay them directly onto the wire. So just like they're laying on the wire in the interior section, I'm going to lay them on the wire here. Now when I'm soldering on a plaster model, I usually just lay them directly against the band. And it gives me a little bit more of a low profile look. There we go. Getting closer. Where are these bands? There we go. And then I look down the front and make sure that it's not lifted up. It's slightly lifted up, so that means I'm hitting a little too hard on here. So I'm just going to tuck these in more lingually. I guess that would be the cardinal direction there. Okay, getting closer. That one's not touching, so I'm just trying to get them just to. I gotta have them to touch so I can laser weld them, because we're going back to the laser welder. I call it laser welder. It's not. It's a puck D3. It's a TIG welder pretty much. So I'm gonna mark this here. Mark that here. So I'm just marking right above my line there. Mark this, right above the line. Woo! Alright. I'm just going to cut these into the trash. Again, I'm cutting above my mark, and I even put my mark above. You can leave these long if you want, but working under the microscope over there, the arms could get, in the way. So right now I'm just going to tack this screw in with a little sticky wax, just to help hold it in place. I've done these sometimes, and I've concentrated so much on just one joint, the whole screw rotated on me, and I didn't realize it, and I had to reset the whole screw. So this is actually, now that I'm looking at it, it feels crooked on me, so I'm going to check, put something level. Yeah, it looks crooked to me. Like this side's a little higher, so I'm going to go back. I'm going to rebend just a little bit. So let me break this off. Lift this up. I'm going to bend these in a little bit, and that should aid in dropping that side down. So that's one thing you got to be careful of, is you could prop your screw up if you have one of your arms touching early onto your other arm. It could prop your screw up where it's not crooked. Oh yeah, that looks a lot better. Yeah, so I'm just kind of making sure this is parallel with this. I don't know if y'all can see what I'm seeing here. Just make sure it's parallel with the occlusion. You don't want it going off one direction. So now I got to make sure all these are touching. So let me wax this down. I may make some adjustments. There we go. Sometimes you can make some small adjustments while the retainer, the RPE, is still loose. There we go. Okay, I'm good with that. Let's start waxing. Let me get some water here. Okay, so I'm not going to worry too much about this joint here. Let me get some, change my angle a little bit. There we go. And focus in over there. So turn that down. I don't know if that's working, but I'm going to change my settings on the thing here. When I move my camera, I'm going to show you my settings I use. So I have this here. It's touching. So I'll try to sorry if that's blocking the camera. You just got to get in the right position. I usually try to do as at least three welds. Mesial, distal wire, and then occlusally. You can't really get under the wire until you could take this off and then do some more welding. There we go. Let's do this one. So yeah, I'm welding it directly to the 036 wire that is welded to the band. So again, I'm still not very good where I can weld and just leave the weld. I'm still kind of learning this. There we go. Whew. My wire that is using to cover the hole where I blew through the band is in my way. There we go. But because of that, I was able to weld it like a madman. That's excellent. Okay, so we got welds, and sometimes you can weld, you know, this corner, then this corner, then this corner, then this corner, kind of like putting lugs on a tire, on a wheel. When you're putting it on the car, kind of work your way around so that you don't concentrate too much on one side and then the other side lifts up when you're not looking, because you really can get binocular vision. Okay, so that is it welded. So now here's the tricky part, and the part you got to take some time with. You got to take this off the model. So pretty much you can think of your laser welding as extreme tack welding, but this could probably go in the mouth. If I take this off and I laser weld underneath some more, I could probably get away with sending this to the patient like that, but I feel like it's just not very good. It's not really rough on the tongue. Again, I'll trim it and stuff, but anyway, many of you that work in the operatory know what this is. This is a band remover. I happen to have a doctor give me some old ones. So when your doctors are giving away old bands and tools, grab them, because they make this part easy. So I'll see how well I took that off. Now what you got to be careful with is you don't want this to bend in any way. These will still bend a little bit. But what I was talking about is you could still come in here and laser weld this on the underside. If you want, let's zoom this in. Come on. Come on, get in there. Get in there. Can I see that? Get back. Get underneath. Come on. There we go. Alright. So what you can do, let me tilt some light on here. You can come back and you can laser weld under here. Okay, Pete. Here and here. And then you could probably send this to the doctor. Now these still tend to bend a little bit just because these bands are very thin, as you can see. They're very thin, so they bend real easy. Now 3D printed bands, we don't have that problem. So that's why I always like to put a little bit of solder, just flow a little bit of solder. So that is the next step. And so let me, well, the duck cam doesn't have any ducks out there. Alright, I'm going to move my camera a bit. And like I promised you before, I'm going to show you my settings. Back up just a bit. Okay, so these are my settings. Stainless steel. I use this one for, again, this is my Lampert Puck D5. I use this one for pretty much thick wire to thick wire, so 036 wire to RPE arm. I use this one for wire to wire, like but smaller wire, like 030, like my soldered C's. I use this one, and then these are all just standard things. So then this one I use for my wire to band. I use this one, and these are pretty close. You can probably get away with using this. If I have a hard time getting it to stick to laser weld, I'll increase this, use this knob and increase this. So I use this for wire to band, I use this for small wire to small wire, and I use this for big wire to big wire, and that's pretty much what I use. These I start using for whenever we go to 3D printing metal, and I'm going to laser weld the screw to the arm. That's what I use for that, one of these two. But that's it. That's my settings for that. So let's grab my model here. Oh, I gotta set up my camera. I'll zoom this in when I get a chance. So I have them. Well, honestly, I don't need the model anymore. Can y'all hear me okay still? Okay, I think I'm doing good. All right, this is a soldering board. Got it on Amazon. Again, I have a link in the description below to my Amazons. Pete, I hear you. Shush. Again, if you're just watching, that's Pete. That's our rooster. He is very loud today for some reason. So I have my flux. Again, I get it from JBC. I have my heat shield. I get that from JBC, but it's pretty much the standard heat shield we use. And here is my trick. Instead of trying to solder it here and trying to block out everything on the screw, and you don't want to overheat your bands, that kind of stuff, I use this. And what is this nasty thing? Well, this is a wax tin, and I filled it up with heat shield. So I just take my heat shield here, and I'll put some fresh stuff in here. So that, this is just plain old heat shield, and I fill it up in there. And this is my little trick that I do. Again, put in the comments below what you like to use. This is a messy business, so just get prepared. Let me get a paper towel real quick. There we go. And this is what I wanted to show you all. I take my RPE and I push it into the heat shield. So then what that does is it provides protection from my soldering. Now if you have a hydro flame, oh man, that will work perfect for this. But if you don't, then you use one of these, which a blazer torch, which is really nice, but anyway. So I'm going to take my little brush flux. I'm just going to put flux on this. And again, it's not going to take much solder. Again, mainly what I'm doing with the solder is just filling in the gaps. Really trying to get this to stick to the band. Remember that hole I blasted in there? I got to be careful putting flux in that hole, because if flux gets on the inside of the band, that solder is going to shoot to the inside of the band, and then I'm sitting there spending many minutes that I don't have grinding out that solder droplet that got inside the band. So I'm just adding flux on here. Got that. Now, if you've noticed already, my bands are empty. So I have my little monojet syringe thing. Actually, I might have to refill this. If I do, it's probably good, because I can show you how I refill it. But I have a little cap to keep it from drying out. But the bands are hollow, and we really got to protect those bands. So I'm just going to take this and I'm going to squish it in like that. Kind of like baking. Like this is the Great Ortho Baking Challenge. And I'm just going to add a little bit here and a little bit to the distal. Because if you know anything about soldering, it does not take long to kill these bands with flame. And I'm just going to put a little bit on the front. I might as well not heat the crap out of those wires to make them dead soft. So now this thing is fully protected and ready to solder. Let me switch cameras over here so maybe you can see it better. Oh, it's so gross up close. So I've put my flux on there. I've sunk it into the heat shield, and then I use my monojet syringe. Now, the thing you need to be careful of is make sure you don't see a gap here, because you don't want solder to jump over inside the band. So make sure it's filled all the way to the rim of the band with heat shield, so you don't get solder. Now this right here wouldn't work on this side, but I'm not soldering that side. So you see this little gap right there. If I do it in the right, yeah, there you see the gap. So I just got to make sure. Now this is the side I blew a hole through. Now I filled that up with, well, I filled it up with heat shield, and so now I've made a wall of heat shield on the inside of that hole. Okay, let's look at this. All right, so let's get to soldering. So I have my regular solder here. I usually just have it coiled up. You can cut off pieces of it. However, I just like to make a handle out of it and get a little, I just push out a little bit of solder. There we go. Take the tarnish off. And then I'll work on, let me dip that in the solder. Get my flame going. Hopefully you can see this okay. I'm just going to heat this. It doesn't take much. I was working on both sides, trying to get it evenly. I'm waiting for that white flux to turn clear, and then I know it's time for me to add my solder. And I'm just going to add, there we go, just a little bit of solder. Again, I've got to get it over all that extra wire I put in there to cover the hole I did. I think I have enough solder. Less is more when it comes to solder and laser welding. You don't need as much solder. But again, I'm trying to make it smooth. Alright, other side. So once you get set up, the soldering goes pretty quick. Again, it does use a lot of heat shield. Heat shield's cheap. I don't know how much that tub of heat shield cost. I don't think it was over 20 bucks. And it lasts a long time. So then I'm just soldering. Again, the front ones, they don't take long. Trying not to. There we go. Okay. We got it. So, I'm going to take this over to the sink. There we go. And steam it off. And let's, is there any ducks out there? No? No ducks? Whoop, hot. Alright. I didn't put a camera up over here, but I'm pretty much just taking a scrub brush and just rinsing off the heat shield water soluble. And then I'm going to steam this, so it might be kind of loud. There we go. So I can actually, do I have a better knife somewhere? Maybe. I actually can take this out now. I'm on the wrong. Take this out now. Let's zoom out just a bit. If I have the right knife, maybe this will work. Come here. Come here. Alright. So just to recap, we have normal 3D printed model, digitally ditched in the computer, printed this way, bands provided by doctors, or band kit provided by doctor that I then size on here, alright, and then I bent an RPE like normal, like you would on a plaster model. So that's why I call this hybrid, or as Perry might call it, the dance, trying to correlate between the two, between digital and plaster. So this was a plaster technique done on a digital model. So if you want to stick with me, you can. I'm going to go ahead and finish this. Let's just get this over with. Get it over with. The finishing goes real quick. Ask your questions below after we're done high shining it and getting it over with. I'll answer any questions you have below. And let me switch cameras. Let's see, I got one more camera here. Okay, let me move over there. I gotta actually move my chair. Thanks to my friend Steve Zara Dental Lab on his YouTube channel. I got these roller wheels from, where's that from? Amazon for my chair. Okay, so, hopefully y'all can see this okay. I'm going to zoom in just a bit. And tap on that. And right there, so, I don't know. Hopefully y'all can see it. I like to use, you could use a stone like this to really knock off those wire tips. Okay, I gotta turn on the thing here. Oh, come on. There we go. Just kind of knocking off those sharp points. Like this one. That's a good example. See how high that, how tall that is? I like to make these flat with the wire. A little more contour into the wire. And then I like to switch over to, I know this blows some of y'all's minds, but I learned this from Jason Brown who's watching. This is just a nice acrylic burr. And it trims solder pretty well. So I'm just kind of oh, there's a little piece of wire that I use to cover that hole when I blast it through the hole. So yeah, that's the thing with TIG welding or laser welding to regular bands. Is you kind of get overzealous, and me, I was talking, I was monologuing, and I forgot to do my settings for it. So pretty much I'm just kind of contouring this, making it all blend in. You're trying to make it hygienic for the patient. Some people call these the hygienic RPEs because there's no acrylic, it's not like a Haas, no acrylic to trap food in. They can easily clean up underneath it. Okay, I'm pretty happy with that. And if you use smaller strokes like this, oh, sometimes they bulge out because I'm pretty much soldering out in the open, right? So this will kind of bulge. So I like to flatten this also because that was built against the tissue. I don't want it to stick into the tissue. And then right here, make sure you know it doesn't connect direct from here to here with solder. You kind of want to see an arch in here so that the gums will slide in between here. So that turned out good. Alright, so let's see if I can take this camera with me. Actually, let me set up another camera. Take another camera with me. I wish the ducks were out so I could show you the ducks. So I'm setting up a camera at my micro etcher that y'all can hopefully see this process. Let me switch cameras real quick. So this is my Veiny Man Sandstorm Professional. If Veiny Man's watching, please give me a call. You know what I mean? You know, work out a deal. And oh, if I can get my hand in here, I got my tripod in the way of my hand. Sorry, don't get sick on me. So I use 50 micron aluminum oxide. I'm going to blast the inside of these bands. So we're going to see what happened to that hole I blasted through. Oh, yeah, I do see some solder in there. But it doesn't look bad. So I think I will go back and take a burr to it. Yeah. I don't know if you can see that or not. I'll try to bring it in a different camera so you can see better. Knock the dust off. And let's take this back to here. Get to the good camera. Well, y'all didn't see any of that, and I am sorry. I'm going to try this a few minutes. I like the idea of plexing screw on second. It will make it easier to arc weld. I've always... Oh. I'm going to try... Hey, Steve! I was just talking about the wheels you recommended for my chair, those roller skate wheels. So, let me... move my camera here. So it looks like I lost some. I'm recording this, so hopefully I'll come back and edit some in the trimming. It looks like I missed all the trimming, and I apologize. But I took my burr, my thing here. I always arc weld everything at the same time. Yeah. Yeah, I didn't change the camera. Stupid me. I'm sorry. I was changing it on the other one, but it didn't come through on the main. Oh, that's... I need a cameraman. I need to get my son back to work as a cameraman. So I pretty much changed this chain and trim that, and I used an acrylic burr to then contour my solder joints. So I've contoured my solder joints, especially under here, and then I want to make sure that there's not a blob of solder right here where the acrylic goes. So if I put this back on here, you can see it's hard because we've digitally removed the gums there. So it's kind of hard to, you just kind of got to imagine in your head that you have made enough room for gums to come up underneath here. But that is pretty much it. And then sandblasting, that was... oh, I bent, see, you gotta be careful. I bent these. I bend them back. I got a little overzealous. See how easily these bend? And then I sandblasted the inside, and you can see where I blew through the hole. And I filled it up with heat shield. So I blew it, so you can see a little bit of a solder right there. So what I'm going to do is take my acrylic, my fine tooth acrylic burr. I don't want to use very coarse grit, and I'm just going to just hit the top of that, just to make sure. Obviously, you don't want a blob, but. So, there you go. That's how I fix when I blow through a band with my laser welder. They're my arc welder. Is that what you call it, Steve? Arc welder? Oh, Diana Lopez. Oh, y'all are talking to each other, not even to me. I see how you are. Okay. This is how can you fitting bands on 3D print? Did you trim molar first after printing it out? Good question. To cover this, maybe not so much. At the very beginning, but when I got the digital scan in, I digitally ditched these. I'll put another video out where I digitally ditched the models here in the computer and then printed it, and this is how it came out of the printer, just like this. Here's a cleaner version of it from another doctor. So I ditched them digitally and then 3D printed it. It does a better job because I like to print them hollow to save resin and all that stuff. So if I print it hollow but then I come back and ditch them manually with a burr, there's a chance I could poke through. I'd have to print solid. What I've done in the past also is print it hollow. I filled this in with plaster, let it set up, and then I'd ditch like normal with the burr, round burr. Let's see, do I have one here? Like I would use a round burr like this, and I would ditch like normal, but you got to make sure you got enough support on the inside to do that. But since I do it digitally, I can print hollow because it does all the supporting and stuff for this band. So yeah, same strength, different technology. Laser versus arc TIG. So TIG, yeah, I was using TIG. Arc is what I use also on my puck welder. And I think, Steve, what do you use? It's from Sunstone, Orion, right? That's a good welder. Looks like it has a lot more band options on it. Alright, so I'm going to change my camera again. Let me set this here. I'm not changing it to the other camera now, so just so you know. And y'all have to disregard my mess. I'm going to try to attempt to show how I pumice this. Alright, let me switch my camera. And let's go pumice this. So this is me finishing it. I've trimmed it with a burr, and I just pumice it with regular pumice. There we go. That picture. Make sure my pumice is slightly wet. Wet it a bit. And I just pumice these joints like they're acrylic. Doesn't take much. So the pumice will actually attack the solder more than the actual wire because the solder is softer. So you can actually pumice away all the solder and leave the wires if you're not careful. So then I also try to get the gum side, try to get that rag wheel up in there, trying to polish that side. I like to polish all the sides of it. And then this back side. Okay, I just have to make sure it's still on the right camera since I missed all the trimming parts. Maybe I'll put it in a shorts, so pay attention. I'll try to recover the recording of me trimming this, and I'll put it in YouTube shorts, and you can see what you missed. Okay, that's good. And you gotta be careful. Even the bigger the band, the more weak they are. And I can crush them. You saw that earlier. I crushed them on my finger. Had to unbend them a bit. Alright, let's steam this. So I actually use a different wheel for my metal. I'm actually going to try to set this camera down where you can see it better. Alright, so I actually use two different wheels. This is for acrylic. And of course this is for metal. As you know, many of you know, pumicing metal or shining metal is, messy business. So I use a green stick. I get this from JBC. It's a metal. It's a green rouge, I guess, for metal. And then I'll polish the whole thing now. Because before pumicing, I was just doing the solder joints. But now I might as well just get the whole thing a nice, shiny. trying to get everything nice and shiny so that it looks good when the doctor sees it and the patient sees it. There we go. And then I'll put it into my little ultrasonic, let it clean a little bit. This is my exhaust vent. I've got a YouTube plan for showing how that's just venting outside, where I don't have to worry about it. So all the dust and particles, pumice particles, just go outside. So I got to clean all this up. I'm going to run some actual pipes from the back of these here to back there. But let me get this out real quick. Usually I let that run longer. And let's go back to here. Turn this off. So I'm kind of skipping a little bit here. Usually I'll run it in the ultrasonic for 5 or so minutes and then let it clean up, and then I'll test the screw and make sure it works and stuff. Okay, so Steve, you use Orion 150. Ah, yeah, that's good. Let me get this. I keep bending this band. And the good thing about these bands is they are flexible a little bit. So, and they tend to get tighter. As you put solder on, you apply heat, these bands will tighten up a little bit. So that's another reason I go a little higher. Let me blow this off just a bit. Ah. Okay, that is it. Oh, thank you. Thumbs up for me. All right. Thanks, Diane. Awesome. All right, so this is it. We're done. So that was it. I took a model, a 3D printed model. I fit bands on I ditched it digitally. I'll make another YouTube video on that if y'all want. Look up Dr. Gruder. His YouTube video. I think he does one of these. I found one. You can find it. Mesh Mixer. Using Mesh Mixer, you can find out how to answer your question before. On fitting bands on 3D printed model, I use Mesh Mixer to ditch these, and then I base them, and then I print them, and then I use the bands from the doctors. So I use the bands from the doctors. This is the doctor bands that the doctor sent me, his kit. So I fit these bands myself. I love it when the doctor sends bands like this, because I know 100% they fit, but also like when they fit bands chair side and then tell me in the prescription which of these fits the model. And then we know 100% it fits the patient. This way I'm kind of guessing, and I go a little bit bigger because adding stuff on there works, but I went over that before. Thank you all for. We're gonna end on that. That is our finished product. Again, sorry for missing the trimming thing. I missed the camera edge, so I'll try to download that and get that on my YouTube Shorts. So subscribe so you don't miss that. Hit the thumbs up if you like this. Put in the comments below your method you like to use for doing this. You know, where are you in your stage? Are you still doing plaster models, or are you doing full digital 3D printed bands, which is my favorite? 3D printed bands and framework and 3D printed models. Where are you in that range? Let me know in the comments below. Let everybody else know. And if you got any tips or tricks, like this, setting it in a big nasty pile of heat shield, so you can do a little bit of soldering on your laser weld. So with that being said, thank you all for watching, and I'm glad hopefully it helped y'all. I think if you're watching the recording, stay to the end. You can see last week's live stream, which was it repair? No, it was Adams class, where I compared pre-bent Adams clasp to hand-bent Adams clasp, and we actually bent a couple to see which one was faster. And hint, it is preformed. But got a last couple. Okay. It's not possible to solder directly on 3D model. No, do not solder directly on 3D model. It will gas. You have to wear a gas mask, and it catches on fire. The model actually catches on fire, whereas the plaster actually absorbs the heat, and it won't catch on fire. The 3D printed model will catch on fire. So that's why you have to actually pull it off to do your soldering. And that's why it's important to get the laser weld or the arc welder, so you can actually arc weld. You can arc weld that directly on the model. There's no flame involved. Once you involve a flame, it will catch on fire. Now, if you have a hydroflux welder, maybe the flame's tiny enough. I don't know. Just use ventilation and stuff. Yeah, Diana, you're welcome. And yeah, later, Pete. I haven't heard him in a bit, so maybe he's sleeping somewhere. But I'll bring a picture up on of him so y'all can see him. He's a beautiful rooster, but I think he hears me talking inside, and he's outside, and I don't know if he wants in or he's just warning everybody about me. So that being said, I appreciate. Ask your questions below. I'll keep up with them. And that's why. Yeah, you don't want to K3 people. You don't want to solder on a 3D printed model. It will catch fire and gas you out. So I'm going to end there. Thank you again for being with us. And let's see, I got an outro here somewhere. Where's my outro? Nope, that's not it. Wait, where's my outro? There's my outro.